All right. So the intro was cut a little short there. There was a file misplaced, and I don't know where that's at. So here we are live for season 14. This is the premiere. We're going to be welcoming a new member, going over the panel here. Starting from the original cast, we have Ainsley 717, otherwise known as Cami. I'm going to screen share. Oh, thank you. I'm mildly illiterate. Oops, 1 second. Oh, Shane, can you take down the screen share real quick? Thank you, sir. I'm going to introduce everyone. All right. So we have Ailing 717, otherwise known. I messed it up again, didn't I?
Oh yeah.
Awesome.
You're in the zone, man. Go for it.
All right.
Okay.
So
we're gonna help you a little bit.
yes,
Okay, Alan. It's if you're in Ireland, it's Ashland. It's
Ashland.
just Ashland. In America, we
Ah,
call it the Americans call it Aisling, and I have adopted Aisling
Aislinn.
over the years. I've had this name long before Flat Earth or long before anything. And Ashland is a prophetic poem. It's history written in poetry, an epic poem, like your epic poem, your tale of history. And again, all written in poetry, and it tells historical tales. And I've always thought that was a wonderful, like the Iliad or the Odyssey are Ashlands. They're perfect examples of an Ashland or an Aisling
Oh,
in
I would
America.
have. I would
So
have
you,
never
yeah,
got that one. Well, thank you.
you would have never figured that one out, but it's not alien. So I am jumping in a little bit, but yeah,
No, you're
or
good. Thank you.
otherwise known as Flat Wives Matter, or I was Bob's wife, Cami and Adele. So in the background on all the GLOBEBUSTERS shows, but yes,
Flat
it's good
wives matter. All right, that's great.
in every way. Yes.
Awesome. And to continue on here, we have Karen B. I'm just kidding. Karen B. We have Karen B. Longtime Globebuster member. And last season, we welcomed myself and Shane. So we have Shane's channel here. All the links will be put in the chat here in a second. And then, of course, we're welcoming ManofStone here, bringing in the Ether Cosmology Blade of Truth, as we call him, to do a little quality assurance around here and bring what he offers to the community. And Stone's been a great teacher. I've learned a lot from him in the year or so that I've known him, and it would be an absolute honor to bring him here to present his work and go over the stuff that he's done, because his videos go completely unrefuted. His arguments are impeccable, and he's great at analysis. He has a lot to offer and teach us. So that's why I brought him aboard. Stone, if you have any opening remarks or anything you wanted to say.
No, I think you sussed it very well. Nice summary. Good to show my BitChute page there. I think what people can look forward to in the next, I think, couple of weeks is that I will be finally also moving to Rumble. I'm going to set up a channel there and re-upload all the stuff on BitChute that I've got, pretty much all of it. Also, a move I'm making because of the nonsense going on in the UK, that people in the UK these days are not permitted to go and visit BitChute, which I find not just disturbing, but also equally ironic, because it's a British corporation. They are sitting in England, but people from that country can't actually visit their site. So instead of driving everybody to learn how to use a VPN, I think I'm going to reissue stuff on Rumble, and we'll go from there too. But yes, thanks for the intro. Good to be here. Absolutely fantastic. Frankly, something I thought would never happen in a million years, that I would ever be on the GlobeBusters platform. But hey, so fantastic that I was incorrect.
Welcome, Stone.
Yeah, it's awesome to be here, and I never thought I would be here either. It's just it's great opportunity to continue building on what Bob started. So
I agree. I think the additions to and on this show, I think Stone doing it and then doing the again fact checking and holding that line. Karen also does that in it too. We want that line on reality. We want that proof. We want the feel of it. You can mix in some metaphysical and some things with it and draw theories, but we have to separate theories from reality and look at things going forward. I love the group going forward. I did promise people that I would not join the Sunday show. I have vocal fry and not the best voice, but I do have fun. I have a lot of passion I'll be a little bit more quiet on the show, but I like where they're going with this, and so we want to liven things up a little bit. If you guys have questions in the chat, I'll be watching some, and we can throw them out there. But you guys, thank you for doing this. I think it's a great group. I think we can go pretty far.
Yeah, it's going to be amazing. And like you were saying, having an objective standard set and then, maintaining that and holding to it is exactly what is needed. So yeah, moving forward, that's the way we're going to do it. And if you guys have any questions in the chat, just tag GLOBEBUSTERS and we will read them. We will read the questions at the end. If you guys want to super chat, all proceeds go to Cami. So sign up, become a member, donate, ask a question via the super chat if you want. And all that goes to Cami. And next we have, we're going to go ahead and
we are going to mention that, like, when you guys do the super chats, if you were to look around at my desk, and that all of your super chats go to funding Cami's magnetics and Ruben's tube toys. I put all of the donations to Very Good Loose with your learning toys and ways to teach children more than anything is I do a lot of exhibits live, and we put together packs for the children. We are teaching in the background. We are teaching children how to do Faraday effect and Bell's theorem and different things. And you know what? The young ones, they're not having to unlearn. They're catching it really, really quickly. They understand it. So that has been like my focus in the background is not the adult world, but the children's world. Passion is still here with the show, and it's important what we're doing and taking what you're doing and breaking it into childlike bites. So our children don't have to unlearn so much. I think it's very, very valuable.
Yeah, that's awesome. Children getting teaching that next generation as they're coming up is super important. So just exposing them to that is great work. All right, so to give a little introduction into today's presentation, we're going to be going over starting with the history of the globe and how it was made. So there's a lot of different, quote unquote proofs of the globe or whatever that'll be presented, right? But everything really boils down to one thing, and it's the latitude longitude system. It's the use of that coordinate system that relates positions of the stars to positions on the ground. That is primarily why people think we live on a globe. And so Shane's going to go over how those models are constructed and what exactly was done to present this coordinate system as a place of where we live by relating the sky to the ground. All right, so start us off with this. This is part one of like a 3-part series, Shane, or a 4-part?
Yeah, we can do 3. This will be 1 of 3.
Nice. So this will be part 1 of a 3-part series on this. And if you want to see the full series, you can go to Shane's channel or my channel and look at past ether cosmology roundtables. And the last 3 or 4 that he's done are all on the Datum and the celestial terrestrial sphere models and all that. All right, Shane, whenever you are ready, good sir, take it away.
Nice, thank you. So my mic level's good. If it drops or whatever, let me know. Oh, it's pretty
you're
low.
good, man.
All right. Looks like it already was dropping. All right. Let me know about that. If you have any questions at any point, panelists, hop in. Let me know.
I have a question. Can you turn your fan down?
It's just a
My
tad.
fan.
You let her move it farther away from the mic. One of the two, yeah.
No fan is on. So what's going on?
Oh, is it your AC? I don't know.
It's pretty loud.
Oh, that's gonna suck. I'm not gonna pull a Karen. So.
Respect. All right.
I can maybe use Chris. Hold on a second. This could be fixed, maybe.
That one, while you're fixing that before you present, I'm sneaking out and getting myself a drink. I can hear everything.
Okay.
Just not see for a minute and not very far. I just left my drink inside.
Mic check, Shane.
Yeah, hold on. It's still not there.
So do we need a little musical interlude in the meanwhile? Is that what? Oh yeah! We'll do those lights and longs long after the shells and glovers are gone. Are you there yet, Shane? Come on.
Okay, somebody sings almost as good as I do, and that's not. Oh no, that wasn't bad. That wasn't as bad as I sing, but that was pretty funny. I almost caught what song was in the background. Almost.
From stones new hit single, Lats and Longs. You can find on his
Not even
BitChute
so
channel.
new.
All right, make this default, and then that should be better. And then I can change this level. And then in here, I'll change it. We should be good.
Inshallah, it works.
All right, how's that? Any better?
Yeah.
That's a lot.
Fantastic.
Wow.
And your air conditioning is on, so you're doing it without it being 95 degrees.
I didn't
Unlike
know.
some of us
God
that are hot and
bless.
sweaty.
All right, Shane, take it away, sir. And if anyone has any questions during the Prezi, feel free to interrupt him mid-sentence because he like makes everything up he's saying on the go anyway. So it's not like he's gonna lose. He's not gonna lose his place. It's fine.
There
So
are no notes. Yeah, this is all.
Yeah, so just go ahead and interrupt and ask questions on the fly.
And if you think I'm saying something retarded, please let me know. That is your job.
Just pull the string and let it fly.
Right. Excellent. All right. So this is probably one of my favorite presentations because it goes through the historicity of when they inserted the globe, how it was made, is it real, where are the ground-based measurements of curvature, right? That's how I approach this. Now, we usually talk about the celestial sphere, like as Alan outlined, the long lat grid, coordinate systems based on angles to the stars. And when you discuss them like that, they're arbitrary, right? The coordinate system is just a grid of X and Y. So it doesn't have any real meaning. And that's what I used to say all the time when arguing it, is that it's based on a datum. Without a datum, it's just arbitrary X and Y figures in space. So the longitude latitude grid is known with a specific datum, and we'll get into that. When you're looking at a map, it's actually just a projected coordinate system. We say this all the time as well. We're going to go into what that means versus its counterpart, the geographic coordinate system. But a coordinate system here, like I said, is just a grid reference system without something to link it to the Earth. And it says here, each projected coordinate system is defined by choice with a choice of a geodetic datum to bind the coordinate system to real locations on the Earth. And that's what we're going to be discussing here. We're going to go into the backbone of how this is bound to the surface of the Earth, because that's really the crux of the argument. So we're going to deal with projected coordinate systems over here in maps, and then geographic coordinate systems, which is this so-called natural state, right? Which would be not the globe, but the spherical coordinate system that is projected. So this is from the very first presentation we did back on maps, and all maps are projected coordinate systems, and they're projecting the geographic coordinate system. Remember, geographic coordinate system, projected coordinate system. When we go into what is the geodetic datum behind it, if you look at just the National Geodetic Survey, the first way they describe it is as an abstract coordinate system. So a geodetic datum is an abstract coordinate system with a reference surface such as sea level. And we're going to go into that in specificity and lots of detail. Also know that there's difference between a horizontal and a vertical datum. Horizontal we're going to be dealing with for latitude, longitude, and vertical is going to be for mean sea level and water depths. And they abuse both of these to get the ellipsoid model that we work with. So if we go into how did they build this model, we can say actually, they claim that it was built by Ptolemy. Ptolemy's first book of geography, or Geographia, also known as Cosmographia, put forth as the father of mapping and cartography, the two-sphere model of the cosmos. He said, in order to proceed, Ptolemy assumes that the reader understands and accepts the two-sphere model of the cosmos. That is, with the two conceptual models of the celestial and terrestrial spheres. And of course, in his model, the celestial sphere is the concentric circle around the terrestrial sphere, with even then describing it as a sphere of infinite radius near where she says stars are fixed to the outer surface of the sphere, which is so vast, etc. So almost word for word describing the Wikipedia entry for the celestial sphere here in Ptolemy's book from 300 BC. Of course, he even went on to use longitude, latitude, reportedly, and denote places with longitude, latitude marked out in stadia. So again, the two-sphere model of the cosmos, we can say, came from this book, back from antiquity. In modernity, though, it's much the same. We have really embodied this two-sphere model of the cosmos to give us the modern globe. We have on the right hand the terrestrial sphere, which we're going to say essentially boils down to the ellipsoid model centered on the WGS 84 geodetic datum. And then they use the celestial sphere, which is obviously, both of these are conceptual models. They're conceptual spheres. There's actually no real spheres involved here. These are both conceptual models. And the celestial sphere has no physical reality, has no mean radius, is said to go on forever, and literally equates the stars to the Earth, right? Maybe you can have a flat Earth with curved stars, or a curved Earth with flat stars. Those are two things are equal, and that's what the celestial sphere of infinite radius relates. So when we're talking about Ptolemy, this is how the two-sphere model has evolved. Right? He put forth that the stars are thought of around as concentric circles around the Earth, and he put that as the backbone for all of map making and how he made maps in the first projected coordinate system and all that. And in modernity, we're doing the exact same thing, except with more technology. So we have both the terrestrial and celestial spheres marked out more, and combining these two conceptual things into a third conceptual thing called the globe Earth, essentially. When we look at the WGS, which is just the World Geodetic System, we look into the history of how they created the models. We'll see when they started, what they evolved into, what the progress was, and all the steps along the way, so we can see neatly, what they're doing. Some different examples of geodetic datums would be NAD 27, NAD 83, and WGS 84. So this is North American datum of 27, North American datum of 83, turned into WGS World Geodetic System of 84. When you're comparing them, they really are all kind of the same. They claim to have different uses and different reference points, but they're all just evolutions of each other. The main factors here are the semi-major and semi-minor axes of the conceptual spherical model, and then the inverse flattening factor. And you can see, just comparing 27 to 83, they're almost identical. They're off a very bit, right? This one's about 70 meters off the semi-major axis, and this one's off like 4 meters of the inverse flattening factor. So as they bounce around to different ellipsoid models, they do remain largely the same. Now, the timeline is interesting because it says, if we start at, say, 1958 to 1972, that's when the World Geodetic System started, and that's where all the models began for global mapping. Of course, right at the year they founded NASA is the year they started creating spherical ellipsoid models that everyone lives on. Timeline progresses a little bit to the 80s when WGS 84, which emerged based on Doppler data. So transit Doppler data is what built that in the first place. And before that, it was all meridian arcs and celestial observations. But from 1984 onward, they started using satellite and astrogeodesy to really confine and measure meridian arcs and get the WGS 84 rolling. What we're going to go into, though, is more, what do they use it for, right? If we're looking at WGS 84, what is behind it? Well, anyone ever looked at the AE map? Yeah, that's WGS 84. Even the dual pole concave AE map, which you just move the center point to a non-north pole projection to get this dual pole, still an AE map, definitely still using the WGS 84. In fact, all modern cartography and all maps are using the reference ellipsoid underneath it all. It's all WGS 84. Anytime you're referencing longitude and latitude with a real life location, that's WGS 84. Modern aviation and maritime navigation, WGS 84. All surveying and geospatial analysis, WGS 84 for sure. Even modern robotics and autonomous vehicles, driving, navigation, the things like the Tesla cars, the Camrys, what are they referencing when they're trying to figure out where they're going to get to something? WGS 84. So it's the backbone behind why everyone thinks they live on a globe, right? So we're going to go into how they create WGS 84, or how they would create a modern reference ellipsoid such as WGS 84. And more importantly, we're going to look at how they verified that, right? Once you assume it's just an arbitrary reference sphere, there has to be some sort of validation process to make sure that what you're doing matches the shape of the Earth, right? Well, that's what we're going to attack, because there was very little of that done. And that's kind of the whole crux of the argument here. They're able to create the two-sphere model with very little pushback because it has very little to do with the surface of the Earth being curved. So if you look in the history, the Wikipedia and Google will tell you that actually we've always known it was a sphere, right? There is no start to the globe. It's been always, it's forever and always, which is why it's hard to take apart the history when you look into it. You're like, obviously it hasn't been forever. When was it inserted? They've made it very hard. But what essentially right about here is when you see some tumultuous change, 1735 to 1741, right after the Board of Longitude was instituted, right after some sea crashes took place, and a whole bunch of history that we know of sort of unfolded from there. If we look at, who is the first to put forth the ellipsoid model, guess, of course, our boy Newton. was like, oh, you know what it is, an oblate spheroid rather than a perfect sphere. And he said, based on centrifugal force and the spinning of the Earth, that it would obviously be a flattened spheroid. And so, of course, they put Newton as the first one to recommend that. And then the first use of reference ellipsoids, as we know them today, happened in the late 1800s. And they right about 1738, 1841, and 1866. And we'll be dealing with this Bessel and Clark ellipsoid specifically later on, and these specific large-scale triangulation surveys that they claimed would best fit their models. And again, a little summary, first put forth by Newton in 1687, and then created to measure 1735. That's the so-called history. If we look over here, we have pictures of reference ellipsoids, but this one in particular, you'll find on Google, it says the Earth, and then the geoid, and then the ellipsoid, and it has arrows coming from the spherical terrestrial Earth as if these are made from the Earth, right? And I think this is hilarious because actually these two models are used to make this model, right? The Earth is itself a conceptual spherical model. The globe Earth is a spherical model, and it's made of these two component spherical models, the geoid and the ellipsoid, and we're going to go into that as well.
Oh, they're just a couple of cute little arrows. You can't hold all that against them.
If we just turn the arrows the other way, I'd be happy with this diagram, right? Like this goes into this, and this makes this, but they specifically were like, no, this is totally real. And from this totally real thing, we get these two arbitrary things. The direction makes a big difference. So they do claim that the WGS84 represents and is attached to the surface of the actual Earth. The process is they do a mathematical transform, they approximate Earth shape by the reference ellipsoid, they pick a point, an origin point, and they tie it to this point. And then for simplicity, they measure the geoid and the ellipsoid coincide at this origin point. So they align it up and they say, okay, this is point P. At point P, this equals this. The geoid and the ellipsoid are equal. And then they do their deflections and measurements from that point onward to make sure that the model's aligned. When we're looking at the total process for how they would...
Can you explain what the deflection is? Like, what does that mean exactly?
Oh, yeah. Well,
tell the lads what we're doing here when we're deflecting.
Well, we get super into that, right? It's a whole process for deflection of the vertical, but you need to know what the geoid is first to be able to figure out the geoid undulation that we're mapping with the reference ellipsoid. But if you want to look at it real quick, essentially is this. If we're looking at the deflection of the vertical, it's also called an astro-geodetic deflection. It's when they don't know where down is, and they have these two spherical models and an actual plumb bob, right? So they're on the plane Earth. They don't ever deal with this topographic surface here ever. They only deal with their deflection of the vertical. So if this is enlarged over here, and over here is what's happening is they have the different types of latitude. They got the geocentric latitude, the geodetic latitude, and all tied to the astronomic latitude. So they don't know properly where down is. So they line it up over here, and then they take an XY reading for the deviation for how much it's off based on these two models being precisely aligned. That's essentially what it is. So it's based on star zeniths that they can't actually know.
Fantastic, sir.
Utter incredulity coming back from my end of town here. This thing about how we assume that the plumb bob is not telling you where vertical actually is.
Yes.
I think that's absolutely freaking hilarious. That's like, oh, no, don't trust your tool. No. You have to factor in all of these corrections. Then you're all lined up with Earth. Yeah, sure.
Well, to be fair, if you live on flat Earth, that's not a problem, right? It makes no sense for us to have to do that. Down is down for everyone. We get it. If you live on a metaphysical geoid, though, where down is any different direction and you can't actually determine down, then you're going to need a verification process for, is this plumb bob really down? Is my down your down? Well, how would you know? So they have this thing called the flattening of the plumb line. It's crazy.
If you think you live on a coordinate system defined by angles to the stars and time, then you'll definitely need to deflect a vertical, because if the star isn't in the position where it needs to be, that's the reference that they're going for and correcting against. So when they go to make their measurement, it's not in the calculated expected position. So they're like, oh, you know what? There must be a reason for us to tilt our plumb bob because we don't know what down is. As ridiculous as that sounds, it's the steel man of their position. And there was something really important on that slide too. It was the geocentric coordinates that was noted. So that's going to be an extremely important concept moving forward, because the geocentric coordinates, latitude or anything involving geocentric in regards to latitude and longitude, is invoking a fictitious observer taking a zenith measurement of a star at a specific time where it's going to be 90 degrees above you, and then using that to relate a ground position. So all of those are like idealized snapshots that are tied together with a fictitious observer, which is going to be an extremely important concept in understanding how they tie the terrestrial and celestial sphere together, which we'll
I have
cover
to,
as we
I
continue.
have to point in why you're doing this, and when they're tagging it to the stars, I just have to point out because I think I love it that they can't trust the plumb bob. But I do have to say that while we're matching it up, even at 90 degrees under the stars, that we're going through, we're looking through on their model, even and on both models, a known magnetic field, a known magnetic, strong magnetic field, something called the heliospheric current sheet, which is a strong electronic current. All of these things have optical effects and cause shift in motion, just like when you put a straw in the water and it bends. Again, your magnetics can and will bend. It's a property of a magnetic field to bend light. It's a property of an electric field to bend light. And so the fact that we do all of this and make all of the adjustments to match up with the stars when we know that we're looking through things that are going to, there is no way to look from the ground and have an accurate, you know, that you're looking through things that have no nautical properties. So why is that never factored in or even discussed, to the fact that like when you pin it and the star has to be the correct and you need to adjust your plumb bob in it to make this model work? Am I misunderstanding this, or tell me I'm not taking you off in a tangent that we don't belong in? Tell me this is connected.
No, they
please.
don't take any of that into account at all. You're right. And they should.
How
And it
dare you
should.
suggest there could be other optical phenomenon to explain why a star isn't directly 90 degrees at the expected position? How dare you? It has to do with the flattening factor.
Oh, okay. My bad. I will pay better attention and take better notes. Keep going.
Yeah,
No,
I
that's
don't.
just
Yeah, I don't know if you
yeah,
caught
there's a-
this. I
it's
don't
a-
know if you caught this at the
I
beginning,
caught the
Cami.
sarcasm,
But we are. Everyone's always known it's a globe, Cami. We've known nothing else but globe.
and that's where, again, that's where they tie up all of our really brilliant minds, is they're all solving for a globe and have to create. You
Yeah.
can't find the actual physics, so you have to create. You have to actually pull away from the actual physics.
You have to create
Because again-
heliocentric physics.
mhm.
Yeah. Well, we accept the coordinate system with which we're presented and
I
which
did.
we're paid to do math in, right? So I think that's everyone's professional. That's as far as they take it.
Okay, excellent. I'm loving this. Keep going. And I do get the sarcasm. I'm not. It's not lost.
So we were talking about how they verify it. One of the ways that they list they verify it is the deflection of the vertical, right? So we were just going over that. That is one way where they quote verify that their spherical ellipsoid model actually is conforming to the Earth by deflecting it all over the place. The other way they would do it is by satellite geodesy, which is, you know, a subset of astrogeodetics is a subset of geodesy. Geodesy is the science of studying Earth shape. So literally baked in the definition is we study the Earth by looking at the stars. Right. The study of astrogeodesy means we're using astro alignment and astronomic latitude to align our geodetic latitude. That's what it means. So we're
Means
going to look at
drawing the arrows backwards. It
Huh?
means you're drawing the arrows backwards. You're literally not trying to get to where you're extrapolating backwards. You're drawing your diagram. You're drawing arrows backwards is what they're doing.
they're making a one model from the other model based on the other
Right.
model. Right. Yeah.
Based on their model. Yep.
Which is why I called attention to this picture, because that's exactly what it looks
Mhm.
like to me, except the arrow's going the other way. They took both of these and they made this essentially.
Yes.
So again, the geodetic datum by definition is an abstract coordinate system, right? It's got horizontal and vertical datums, and it's an abstract coordinate system. So the other component, which we could look at as a fudge factor, is the geoidal model, right? We went over the ellipsoid model, the ellipsoid datum, the WGS84. There's a completely other model that works in conjunction, as we looked at with the deflection of the vertical, that is the geoid. And the geoid is a model of equipotential surface. So it's supposed to be modeling the gravity field. And again, it's a big having to do with nobody knows where down is. So they have to use gravity deflection to figure out the definition of down. And over here, we're going to deal with this when we look at sea level. This is the height, how a ellipsoid, geoid, and orthometric heights are determined. It all has to do with above what, in reference to what, like height above what? Is it the surface of the Earth? No, it's the surface of this reference ellipsoid. So that's how all heights are determined. And we're going to get into that with satellites and ECF and how they claim that ECEF data can prove a curve. We're going to dissect that as well. But at the heart of all that is this other model called the geoid, which is a equipotential surface, meaning that by definition requires a perpendicular directional relationship to gravity vector, meaning it has to be perpendicular to the direction of gravity. It's just fancy words of telling them this is how they're going to figure out where down is. Nobody knows where down is when you're living on geoids and ellipsoids. So again, in conjunction with that, we have the ellipsoid, and these are always used together, the ellipsoid and the geoid. And does the reference ellipsoid conform to the Earth's surface? No, they say it doesn't, even in their own definition, it certainly doesn't. And it doesn't claim to prove that the Earth is a sphere. It is at its heart a conceptual model, making the calculations of latitude and longitude, elevation, practical and consistent. And they say that the ellipsoid parameters are derived from observations of surface and gravity fields. So ellipsoid are derived from the geoid and vice versa. And like Alan pointed out, one of the main ways they quote confirm this is with the deflection of the vertical, which its actual name, I like to call it, is the astro-geodetic deflection. And again, it's when you're combining the astro and the geocentric with the astronomic and all the different types of latitude. What they use it for, like we went over here, is sort of measuring how off their models are based on the zenith of a star, while taking into account zero of atmospheric opacity, the way light works, Compton scattering, the incoherent light scattering would affect. And none of that is taken into account. Everything here is like, oh, this is how our ellipsoid is not matching our geoid. So the deflection of the vertical is how they get that done. How they would develop an ellipsoid model, of course, is with the Eratosthenes method. They would just say, hey, based on the sun angles and the distance between GP of the sun, we're going to base that for how to make our ellipsoid model. So again, as Alan pointed out, it's arbitrarily pointed towards the center of the Earth, meaning that they're just at the center of an arbitrary coordinate system. And from that center, they make measurements to say, hey, this is how we're going to have our ellipsoid model. And this is how one of the ellipsoid datums can be created. Of course, the history problem is that when you start to look into it, we've always known this to be this way, right? So the history is, it's always been known. We started with, we always known it was a sphere. I always thought that was funny and obviously bull, but we'll take it at its face for today. And if you look into it, they'll give you this blurb right here where they say, during the Age of Enlightenment, our hero in time and space, John Harrison, who created the marine chronometer, which was finally a way to determine longitude at sea. And that's what brought the spherical Earth, or the graticule, into actual maritime navigation right about 1735. Now, this is the story, absolutely the story, but it's not true.
Shenanigans.
Yep, I would say it's bull. One of our, when we get to our maritime presentation, the third presentation in the series, we'll dive into this specifically a lot. It'll be most of the presentation. So we'll go into how that was abused and misremembered and definitely abused.
Misremembered history.
It really is misremembered. I've seen this history on it. That is really good misremembered. That's the perfect word.
Like, we'll give them the benefit of the doubt. Yeah. So let's look at real quick, again, one of the main methods that they verify their ellipsoid model that they have, of course, just assumed so far and never looked back. No one's ever measured anything. The way that they claim to, as we touched on, is measuring meridian arcs. And this is a book on geodesy from Oxford at the Clarendon Press from 1952 about how to deduce the figure of Earth from arcs. There we go. So what they would say here is that you can aim to create a reasonable spheroid and a best fitting spheroid, which can be used as a datum by deducing from a geodal survey. So this is how they determine their spherical datum, is they measure meridian arcs. Well, before we get into that, what the hell is a meridian arc?
What year is that they were doing this, or is that it hard? How long ago?
This book was from 1952, and they were describing processes from prior to that. The one that we're going to go into is 1740-ish, around there. So right about Renaissance and right about the time of the Mercator. Then right after that, that's when they pretended to do these surveys to measure it out. So that's what we're going to touch on. But this book is just going over the process and saying, hey, how we've always known, how do we measure ellipsoid models? Well, we use meridian arcs. And of course, you have to know, what is a meridian arc? Well, it's a fake line. It's an arbitrary made up line for the coordinate system that doesn't actually exist on the Earth. So this was perplexing to me at first. I was like, how are you going to measure something that isn't real? They're imaginary lines that run north-south on the graticule, right? Not on the Earth. Latitude and longitude lines don't actually exist on the Earth. They exist in the coordinate system with which they're defined.
Take a
So
look
how
at
are we
the
going to measure?
take a look at the language right in that slide. If the line is long enough, 70-kilometer long line, yet they're surveying it with great accuracy, as if there's no visual distortion between those 2 points at all due to atmosphere or anything else. No, no, yeah.
Well, this is saying you'd have to measure at least 70 kilometers with great accuracy before this even has meaning, right? Which is the second part of this slide. Is that I'm not sure if I agree with that, but they're saying that, hey, this process of measuring fake lines on the Earth can be valid if you measure at least 70 kilometers. Well, guys, they measured way less than that when they did all of these measurements. So that was from the Astronomical Society of Southern Africa, which is where I got this from. And that's what the definition is from. And they're saying, hey, look, if the line is long enough, if you get at least 43 miles, 70 kilometers, then you can fairly deduce the curvature of the Earth. Now, I don't think that 0.175% of a 40,000 mile circumference is actually sufficient to deduce
Not
the
very
shape of the
numerically
Earth.
significant, no.
I don't think so, but let's again give them the benefit of the doubt because they won't even meet this threshold. It won't even come to this amount. It'll be much less than this that they'll measure and then claim, boom, we know the shape of the Earth. So this is kind of like the craziest part. And this is, as a flat earther looking into this, the next few slides are the only slides in which they actually even reference the surface of the Earth at all in any way whatsoever. So all these conceptual models and mapping, cartography, celestial translations, coordinate systems, datums, all on arbitrary ellipsoid models, nothing to do with the surface of the Earth. This will be the only time we measure the surface of the Earth. And we're going to be talking about specifically measuring meridian arcs, right? And this is the Clark ellipsoid 1866, which surfaced from the evolution of the 1927 or whatever. So, or was the evolution, I said that backwards, evolved into the NAD 27. When we look at, oh yeah, real quick, no matter which formula you want to use, the difference between flat and sphere over 70 kilometers is something like 384 meters, as we said, arbitrary. Maybe not enough to compare globe to flat if that was the goal, especially if you're using this method to deduce the overall shape of the Earth. What they would do is set up grid lines and networks of these quote baselines, and then they would actually use astronomical latitude to calculate the batch. So not only would they not measure all of this, they would measure a tiny portion of this with rods and chains, and they would look up at the stars, deduce their latitude, and then calculate it based on that. If we look at, what they claim to measure, they say that they measured 10,000 kilometers for total arcs combined when they're doing this. However, that is misleading because what they're actually doing is counting all of the calculations as measurements. You have to get into it and say, okay, where are baseline distances actually measured with rods and chains? And then you'll get into it. Well, those are only a few kilometers, 1 to 3 kilometers long. So we actually only measure 1 to 3 kilometers, and the rest was calculated using angles to the stars. And again, from their own words, you need to measure at least 70 kilometers before it has statistical meaning in any phase. So we're deducing the shape of the Earth by, quote, measuring meridian arcs, and we're measuring meridian arcs by calculating them back to the stars.
Didn't
So
someone just recently measure a meridian arc?
I think so. The TFE experiment, I'm not sure, I didn't look into it, but they claim to have done this on the Earth. And I think that if they were to do so absent astronomical measurement, I would be really interested to see how they did it. But I'm almost certain they did a latitude calculation like this to deduce based on the stars what the difference would be.
Unlucky, since there's no other way to do it then, huh? Because if there was, the boys would have done it, right?
So if you take a trundle wheel and you go 60 miles or whatever with that trundle wheel, that would be a great.
Your mic is wildly fluctuating, by the way. It's not dropping super low, but it's going super high to where it's kind of jarring.
All right. Let's try to, I'll switch this device to this one, and then
you're having a little astronomical deflection of the microphone adjustment. There's some gravity anomaly there. Newton's bucket. Who knows?
I got it. Ready? Oh no. Close that one. That's the static mic button that I have. I didn't set it for the new crisp device. There we go. All right, that should be good. Should keep it constant. All right. So again, we're determining the shape of the Earth based on a distance of at least 70 kilometers, which they didn't measure. And even if you were to measure that whole 70 kilometers using any of these formulas, would only be a difference of 384 meters. If you look at the African Astronomical Society, from which we're getting our data, these are the diagrams you'll find on the website of them doing this network and setting up meridian arcs and actually measuring the surface of the Earth. Now, again, limited to baseline
Dude,
measurement.
can you go back to that drawing?
Yep.
Dude, they look like they're hella measuring the Earth right there. Like they're getting it.
This guy looks like Adonis in a statue. He's got three flanks.
This is how you do it, boys. That's how you measure the Earth, man. That's crazy.
Yep,
All right,
these
go
boys
ahead,
are measuring meridian arcs over here.
Dude, look at them. They got their equipment out, and that guy's pointing, giving instructions. Everyone's listening. That guy's checking his level. Look,
it's classic white guy telling all the black guys what to do.
Yeah,
I mean, just like, holy moly. Oh,
well, it was in Africa, right? So it's Astronomical Society of Southern Africa. Don't they have an apartheid issue going on or whatever?
continually.
If you zoom in close there, though, you can see that guy's like, what? Why is my plumb bob not level?
Yeah, right here. He's confused. You can tell. Right. So, go ahead.
That's wild. That's just what I'm looking at it, and I'm thinking about what they were trying to do with Brian Mullins and the forcing the line and the different things. And the accuracy it did. I'm trying to see with the contraptions they have with the meridian and arcs, because again, those aren't very. They're certainly not 70 meter long little pieces that they're doing or connected. That's amazing. Again, what they're doing or what they're trying to depict there. It's just crazy. It just
more
looks
like 7 meters, not 70 kilometers.
Right.
They say rods and chains, right?
Shane, in the chat, Michael Boylan says the TFE group used GPS to determine latitude and measured in between using that.
Well, there you go. That's completely dismissible then, right? As we'll get into.
No, they measured the globe. Your hand wave dismissed. It's globe. How do they even GPS if it's not globe?
It's definitely going to be investigated with specificity towards the end of this. That's a big part of the presentation, how we determine ECEF coordinates on the datum without using a reference ellipsoid. So that's the method.
Awesome.
It's fine.
Got to cover all the bases, boys. That's what we're here to do. Cover every single aspect of how they've inserted the globe into everything. Because just when you think you're about to calculate a distance, guys, guess what? To calculate the distance, you have to use the radius of the coordinate system. They're always sneaking it in there.
It's crazy, man. I went into this looking for all right, well, they're going to measure the Earth at some point, right? Like they're going to show me. Nope, never found it. 6 hours later, into all this stuff, every model, alignments, deflections, astrogeodetics, a whole field of science. All we do is we measure a little bit and then we calculate based on the stars. That's what you'll find every single time.
Margin error? Never heard of it.
Never met her. Oh, dude, wait, isn't the margin of error bigger than the actual deflection difference or whatever that they claim to measure?
By several orders of magnitude, yeah.
Dude, they pranked us so hard, boys. They got us. They got us real good.
That was for spherical excess and reciprocal zenith angles using optical measurements at the specific altitude that has the most refraction. I think that's what that pertains to. Because then the error is bigger than the excess you're claiming to measure to prove Earth shape again.
I think baffle us with their bullshit is like they went all out here. They went all out.
I think my conclusion at the end of this is that even though this doesn't actually show the shape is not a sphere, nobody cares. Like nobody cares that it doesn't measure the Earth.
No, because it is a that, and they're working on getting it to measure it. But just because
it works,
because you're starting with the sphere, so you have to solve for it. So yeah, you got to make it work. It is crazy.
Internally self-consistent is how the model works, right? That's what they do. So again, measuring meridian arcs, which are imaginary lines on the Earth, which don't actually exist, right? Determined from the stars. You measure a tiny little portion of that, and then you go look at your angle of the sun or the angle of the stars, and you calculate your latitude based on that. Well, how? Precisely using this formula, right? This is how they would calculate the distance of the length using what they would measure, and how they only need a tiny portion to be measured to insert into here to use the flattening factor that they were going to get from in the first place. So when you're saying only a small portion is directly measured, it says if you look at what they claim to have measured versus what was actually measured on the baseline measurements, less than 1% of a total arc length is even considered before they, quote, measure the whole length, claiming to span hundreds of kilometers. And again, they use triangulation methods and astronomical latitude determinations at key points. So they set up base stations along their grid, right? And then they calculate continuously based on astronomical latitude, based on using the only tiny portion of the baseline measurement. So that's how it's done. Less than 1% is measured, 99% is calculated.
Oh, that sounds
This
familiar.
it takes me right back to 2020. You guys remember that really nasty election that went down? And there was fraud allegation everywhere, and they went to Arizona and they spent millions of dollars saying, okay, we're going to look at all the votes here, guys. Oh, no, wait. No, we're not. We're going to pull 50 votes out of that box and 50 votes out of that box and 50 votes out of that box. And now we know exactly what's happening with these 2.8 million votes. All good, boys. All good. No need to look any farther than that.
Not dissimilar, huh? Kind of crazy.
The sampling method.
Yeah, especially when, like, all right, so we're going to determine the shape of the Earth. If you look into Eratosthenes, there's a whole similar situation because he claims to have, measured the circumference of the Earth using sun angles, but he used a known distance of 800 kilometers. So then that comes down to, that's just a meaningless ratio unless, how did you determine the distance between those two cities? That would be the main factor with what you get at the end result. And if you look into that rabbit hole, they're like, first he used Bamatis, which are old school geodetic surveyors, but that's not really a true story. And then they're like, well, maybe the interns did it. Maybe they counted with Roman steps, 800 kilometers. The stories get crazier. The point is nobody knows how he measured it. It was just previously known. So they're using a method of measurement where the measurement had to be previously known. And we're still doing that today. Crazy circular logic. How you could use geodetic surveying to measure anything is also a conundrum, as we'll see, because that requires the dimensions of the Earth to already be known as well. So how you're going to use the model to measure the model is beyond me. Seems asinine. This is about the Clark ellipsoid and, of course, how they would measure the corresponding latitude. So, and again, just the summary, they use basic baseline distances on the ground using rods and chains, very small proportionally. And then they determine the lengths of much larger arcs using latitude and baselines. And then the majority of the entire arc was not measured, but calculated from the network of triangles extending from these baselines. And I think we showed what that looked like early on, but here's what it would look like right over here. So they measure a tiny portion of this. If we look really closely, I color-coded a to-scale size portion of this meridian that was measured. It's this little tiny dot in the middle over here. You can almost see it.
You can almost see the pixel. Yeah.
That's representing the portion of Earth that was measured along the surface before they deduced the whole shape with the meridian arc measurement. Man. All right. So then if you ask Globers, right, well, no, they measured it and they continue to measure it and it's always known. So yeah, as we know, they did measure. They measured short, carefully chosen baselines, and then most of the network was calculated, never measured directly. And in all, only a tiny fraction of the total distance used to confirm the whole ellipsoid model was measured directly. The overwhelming majority was calculated from the initial measurements. And that is what gives us the modern two-sphere model of the cosmos, the terrestrial and celestial sphere combined into one. Now, in modernity, we have redefined latitude and longitude to be specific to a spherical coordinate system. Latitude gets defined as angular separation east-west, and longitude angular separation north-south. So that's how they define it in modernity. But that would give you the spherical coordinate system. Prior to like 1680, when the Mercator came out, latitude and longitude had a different definition. They just meant breadth and width, or length and width, But then they redefined these terms formally in 1866 at a convention. And then prior to that, they did it when the Mercator came out. They defined latitude and longitude for about the turn of the 17th century as defining as angular separation on the graticule. Of course, graticule is not a map projection. It is the gridded network of latitude, longitude, the pattern of meridians and longitudes that they say conform to the surface of the Earth. But again, it's just an abstract coordinate system as we started out with its definition. Like I said before, if you read Ptolemy's geography, he had claimed to have put 8,000 coordinates in this coordinate system using latitude and longitude in stadia. Like he put landmarks, mountains, cities, sites of war times, all of these things were noted in his book as just pages and pages of coordinates when you read it, it's really weird and off-putting. And he put it, apparently all this was in Stadia. And of course, he used astronomical basis to derive distances and positions on the Earth from the stars and from the celestial sphere. That was also his claim to fame. And of course, in Wikipedia, he so-called revolutionized cartography by using astronomical means to measure the Earth.
Now, I have a question for you, because I'm just sitting here thinking and going back and saying when they're making the grid, what would be the reason on making your grid other than to pull us again, where you have the latitude lines running parallel and you have the longitude lines coming up to a point? In other words, you're using on it where again you don't get your perfect squares, you don't need to. But there would be no reason. I mean, you could slice it and grid it differently. With the sphere, you could make it that you had an east and a west point on the side of it and grid it out that way with an east and a west tip, and do it again where you have like your longitude where it comes into a point. Or you could even slice it the other way, like from different angles, and mark your latitude, longitude on your hemispheres, just keeping it a grid in boxes. You can put a box grid over a circle just fine and do it. But I mean, I almost feel like them tying it to that geographic and making your latitude and longitude that they work differently, that one is again running parallel and one is coming to a point. I feel like that is a way that they easily can confuse people. Or again, I don't know what would make you, if you were making a grid, necessarily do it that way, that you had your lines running again. You're such a line, they pick different patterns for the north and south and the east and the west. Why? Just to throw out there, something you wonder about.
Well, I mean, there's an argument to be made of zero can be arbitrary, right? They chose Greenwich meridian to be zero, and the spherical coordinate system wouldn't matter where zero is. That's just the point of origin. But that's really just to confuse people, because you're already operating in a spherical grid. Once you decide that the graticule is a conceptual sphere, then it has a bisecting great meridian known as an equator, or any part that divides it into two equal spheres, and then you have your northern and southern hemisphere. But really what latitude and longitude was an expression of the stars, right? The latitude was the declination at the angle at which the star appeared, it circled, and the longitude corresponded to the time at which it would be there. The way that they get longitude in modernity is they take 15 degrees per hour, the celestial rotation, and they do, 360 degrees divided by, the equatorial circumference, etc. And that's how they get that definition of longitude. That's why the modern coordinate system of right ascension declination converts right to latitude, longitude by converting longitude to right ascension using the hour angle transformation and doing this 15 degrees per hour scale. That's how they relate it. And in fact, that's like the crux of my argument here, is that if latitude and longitude was reverse engineered from observations of the sky, then not being based on Earth shape, then you have these other models, which, the concept of a spherical Earth gets imposed on the model via corrections over long distances. Then the hypothesis is the curvature of Earth is an illusion created by astronomic and geodetic measurements and corrections artificially aligned to make the graticule conform to celestial observations. Right, so that's what the whole model comes from, is that, well, we know that it's observations of the sky comprise the backbone of the coordinate system, and all they did was take one coordinate system and convert it one for one to the other. Once you have right ascension declination, you can determine latitude, longitude, because they built one from the other. They are directly related via the time component.
No, I think it's interesting because I know that when they plot the stars, the plot map that they plotted on is really interesting. Have you seen the maps that, I don't have it in front of me, but bringing it up? But yeah, that's interesting too, and it shows exactly how they coordinate and wrap it. I'll send that to you.
Well,
in the background.
We can go to the other presentation real quick then, if you're gonna. Let's just see. I think I have.
I'm messing you up. I'm messing you up your flow. Karen, you're being real quiet. Do you have any questions at all, or?
No. I mean, I'm just listening, and also I'm like, it's painfully hot up here, and I'm kind of miserable. But I mean, but when you ask, like, why did they do the grid the way that they did? To me, it's like like what he said. It's obvious. It's because of the way the sky
stars.
Like their meridian is arbitrary, but where things, everything going around something in the center is not arbitrary. Like that's the way it is. So it makes sense that.
Where's my video? There we go. But yeah, this is what right ascension declination breaks down to, right? If all the stars have a position, and this is just a projection of the celestial sphere, then this star will always be at this latitude for everyone forever. The only time that it will change is what time it'll be there, right? 15 degrees per hour, so it changes. And that's how they get longitude from right ascension declination, is this essential picture. But you said you were looking at one of the old ones, and I used to laugh because the old maps projections just look a lot like star fields to me. Right? If you're going to project a star field into a map, it looks a lot like this. They're the same projection. In fact, you can apply the same projections to the stars to get the same map shapes as you would with the geographic coordinate system, which I thought was super interesting.
The
This one I
old
don't-
two-sphere model.
Yep.
This one I don't know if you can see and do it. I'm pulling it from a piece of paper instead of this. And let's see, I'm pulling it up to the camera. But this is an actual grid on how the flat model is how you see the sky and how they map it in astronomy.
Stereographically projected right there. Yeah.
Right there. And then again, this shows exactly the coordinates on how they take what they see flat from the ground and wrap it. Now, I actually tried to map the ground to this and it doesn't work with the latitude, longitude, and got to the thing where you're looking at our sky is actually bigger than we think. It's not going to map that well. And it's really easy if you spread out the land. We have pieces of land the way that they folded the globe, and we have a lot of pieces that would be off of the map in our coordinate system. I'm not saying it's not there, but I'm saying that if you put your map underneath, if you open up, again, we're just doing other things. If you opened up and unfolded your globe and connected all of your lines on the map by doing that, and you like this map has got all of the lines on it, you just wind up with, if you keep things somewhat in compact, not stretching or doing this, you just wind up with open areas that we don't have lines on. But it's funny where you wind up with the open lines you don't have lines on. That's where like our South Atlantic anomaly is in the Indian Ocean, where you can't go. In other words, there's a lot of places on our globe that we're not allowed to go to. You don't go to the ocean in the South Atlantic because, again, there's a South Atlantic anomaly. It's dangerous. You can't, nothing sails, nothing travels. We have a lot of these areas that we don't go to. And personally, I think a lot of these, because our lines separate and cut and restart again in order to keep some integrity, is my opinion. But just a thought. Like
Well,
doing
I
it,
think-
kind of
I think-
messes you up, but it works with what you're saying perfectly. It's
No,
like
it kind
what-
of, I think it kind of relates because specifically to use this coordinate system too, right, Shane? Doesn't it work within a specific, like to get that 15 degree per hour relationship to where it's going to match up to a position on the ground? Yeah, it's only applicable in a certain elevation wave band.
Well, we're doing
So it's like,
celestial
so
navigation.
it's like fitting it to where, like, it has to be assuming 15 degrees per hour over a sphere when
I'm sure, but if you flatten it
When-
out, it comes out a
when
little
it-
bit differently.
when it's like that's just like it's moving at 15 or approximately 15 degrees per hour, but only in the optical wave band do you get the 1 degree per 69 mile relationship to relate it to the terrestrial. So it's like those
Right.
corrections like offset that
Mhm.
tremendously when you kind of think about it.
Yeah, anywhere you'd have to use G.G. Bennett celestial refraction or 15 degrees or lower, you wouldn't get an actual direct linear relationship with 69 miles per degree when you're using an optical angle.
Alpha me more with your bullshit, baby. Keep going. Keep going. I'm listening.
But what Alan was talking about is the zenith alignment, because the way they created this model is they took a point P, right, on the celestial sphere, and for every point P on the sphere relates to a specific point on the ground at a time, because the stars rotate around, they relate it that way. So that's how they created the celestial from the terrestrial and related these two things together. That's definitely how it went down. But just to summarize here, so geodetic datums are the abstract coordinate system are ultimately self-referential frameworks that remain internally consistent. They're actually not proof of Earth's, as we went over, motion or curvature. What they are is abstract systems that are internally consistent. So when you do calculations within the datum for the datum, it outputs the datum, right? That should be clear and basic to everyone. It's, you're not going to get anything besides what you put into the system, and that's how it's all set up. Now, not to say that Google Maps and WGS84 isn't accurate and doesn't work. It absolutely is, and it does. We use it all the time, right? So then we're just saying it doesn't actually conform to the curving shape of the Earth because of all the things that we're going over. When they went to actually measure it, they measured 1% of a meridian arc and calculated the rest based on the coordinate system that they implemented. If you look at modernity, like I said, now it's used in GPS and satellites, and we're going to go into that a little bit. The premise of this is that there was a glober over in Ether Cause who was like, hey, we intercepted and pulled some receiver data from the ECEF and we plotted it, quote, raw, and it shows a deviation in the height that is a curve. Thus, GPS show the Earth is a curve, right? So we had to look into this. Turns out, actually, that's not how it happened. It is in reference to a reference ellipsoid, not a surface of the Earth. GPS is a great example of something that operates on WGS84 and not in reality. So we said that WGS84 itself was made from Doppler, right? It was created once satellites were created. They quickly used them in astrogeodesy. They were like, oh, this is the much better way to, quote, measure the Earth, because they got away with their internally consistent measurements within their coordinate system, not even talking about how they created two other coordinate systems for which satellites to operate in, ECEF and the ECEI. So we're going to get a little bit technical here, but ECEF just means Earth-centered, Earth-fixed. It is a arbitrary or not tied to anything coordinate system in 3D space. So you got X, Y, and Z, they're arbitrary. But what it's referenced to and always is in the center of the reference ellipsoid. By itself, they say the ECEF is actually relative to the center of Earth's mass. But we're not looking at the center of the Earth, and this isn't related to the center of the Earth's mass. The coordinate system just references 0.0 in the center. So what they actually say is that the center of the reference ellipsoid happens to also be centered on the center of Earth's mass. So it's not that the reference ellipsoid is the center of ECEF. It's that they're both centered at the center of Earth mass.
That's hilarious.
Right? Because our argument...
And keep in mind real quick, to do coordinate system transformations for geometric shapes, you need a common z-axis alignment. So this center point alignment here, this fictitious observer that's going to be referenced for geocentric coordinates, etc. This is the crux of it, is building upon this to make the models merge and be usable, right? If you have a celestial sphere of infinite radius, what do you do with that? That doesn't make you can't set, it has no application. But what they do is they merge them together with at that center point and arbitrarily set it to 3959. So then they have two spheres that are 3959 that relate to positions on the ground at specific times. Whew.
Nope, they line them right at that 0 point and they rotate them axes, and that's how they get all their corrections, and that's how they determine zero, and that's how they determine the surface. That's it.
Now I know on the this could be off, but it's just something that's nagging at me or whatever. I know on the WGS84 system on the data set, that what was really interesting, I know Bob did a show on it years and years ago. It was a really great show, is how classified it was. Like they let you use, like, apply your stuff to, like, run it through that.
There's two different models. Yeah. There's a classified model, like a military model that we don't know about, and there's even
right,
like a GPS band that's like gives, like, military positions and stuff. So it's like gives different than what civilians would get to.
so they do it. They supposedly do it or keep the shape of our sphere a secret for military reasons, or for, like, on the map. Okay. Again, because it looks like it would just be so easy on the globe. But yeah, I know that he went into the how deep secret it is, but it's not that they're hiding anything on how it works as much as locations. Do you think, or why do you think it's so top secret?
Oh, locations, because they couldn't do really anything else with it. It still has to be like the same kind of coordinate system. So just locations, you would just do that. You would just have it offset stuff for the public.
Yeah, I didn't even look into both data sets. I tried to get some actual data just for mean sea level, and the process was a bitch. I got to tell you, signed up, do this. Where do you work? Where's your organization? What are you going to use it for? It was like, what? I just want a spreadsheet. I just want to play with a spreadsheet. Why do I got to give you all this?
Real quick, while we're touching on GPS before we move on, a big thing that keeps GPS internally self-consistent is the relativistic physics, so-called, in adjusting the speed of light to be constant. So what they'll do as satellites pass over ground stations, whatever a satellite is, it'll make timing corrections to make sure that it's at the right location in the coordinate system. So they'll adjust the speed of light to conform to what it has to be to fit this coordinate system. It's not like they got this new thing, right? And they're like, oh, let's launch it up here, and look, it just happens to measure the globe. No. All the inputs for that thing to make it useful are timing corrections to specifically put it at the locations that it's going to be referencing to be useful on the coordinate system itself. And those are all back-end corrections that we found that they do.
Yep. And we also referenced Wolf and Pettit. I thought I had a slide for it. I was looking here. We're the first to, quote, get uncorrected SAGNAT corrected data, and turned out that was also corrected. So they found it was all pre-corrected for meridian corrections, timing corrections, etc. So if you even if you just go and ask, like, can you use Earth-centered, Earth-fixed coordinates to show the shape of the Earth? No, it'll always be referencing the surface ellipsoid. And that's pretty much well known and established. So I thought it was funny that our globe friends were arguing the opposite of what the basic Google search will tell you is not the case, right? It's not like in pure ECF without a reference surface, you have nothing. You have cloud of points in 3D. There's no information which constitutes the surface. There's no way to know where 0 is, right? Like if you can't determine where down is, then how would you know what this what this Y coordinate is in reference to? The height above what is what it comes down to, and it's always above the reference ellipsoid. So if you look at Wikipedia, it'll give you the basic coordinates where they say you have to use them in tandem. Latitude, longitude, and ECF go hand in hand because ellipsoidal and Cartesian coordinates have this nice handy conversion. But again, if you look at the, quote, raw data of just GPS positions within the ECEF, it's always in use of a reference ellipsoid. That's how you know where the coordinates are. The problem that we ran into is the height above what, as we were dealing with the plight of the plumb bob, right? When you have your geodetic and your astrogeodetic deflection, if no one knows where down is, the other problem is the height above what? If we have a height of an object, where's the 0? Is it above the geoid? Is it above the reference ellipsoid? Is it above the surface of the Earth? Right? It's the same thing that they do with celestial navigation. They make up 5 different types of horizons. You have your geodal horizon, your celestial horizon, your apparent horizon, geometric horizon. Which fake horizon are we going to use for this one? It's the height above what? So they do say that the level of ground changes, and they have to have a model to model the different undulation, they call it. They call it the geoid undulation. But in terms of GPS coordinates, it's always in reference to the height above the reference ellipsoid. We're going to get into tidal gauges in just a minute, but this is the same formula. They have the supposed curved surface of Earth, the definite curved surface of the conceptual geoid, the definite curved surface of the conceptual ellipsoid. And you get the height by adding all of them. So this is the H height. It's going to be the height of the Earth's surface plus the height of the ellipsoid. So they're using the ellipsoid model to determine the height above what, even in raw data. So there is no raw ECEF that is plotted absent a reference ellipsoid. Even when you get into the nitty gritty of it, which we're about to in just a minute, for pseudo ranges, carrier cycle counts, Dopplers, and all of these bands tackled by GNSS, it still uses internally consistent WGS84 corrections and heights above the ellipsoid model. Some of the other ways that they induce curvature, we'll call it, is during data processing. They do forms of interpolation where, previous values help determine new values, and they can only do that with comparing the values to a known model so they can get a predictive algorithm. They use things like least squares and Kalman filtering, which also are applied to ECEF, which are always defined and computed relative to the reference ellipsoid. And then you have things like an integer ambiguity resolution, which is like carrier phase ambiguities, which get resolved via a model, which is based on the WGS84. So without assuming a model and using a model, none of these problems would be able to be addressed. Here's an actual example of someone trying to plot the data and having some issues. This is from like a forum post somewhere. And it goes over the pseudo-range equation and how they would get the data. And then, of course, tackles the problem of H, or Y, the height above what? How do I know where the height is? And this guy's seeming to say, hey, there seems to be a difference in the height that I get from the ECEF versus the height of the reference ellipsoid. And that's what he was going on about. So all this to say that all ECEF are calculated using the model, in this case, WGS84, which is assuming a curved Earth. The raw carrier phase measurements are processed through algorithms like least squares, which inherently use ellipsoidal Earth model to resolve the receiver positions. Pseudo-range and carrier phase measurements are always transformed to ECF using satellite positions calculated under the WGS84. If you were to plot the data in this, it'd be a consequence of this model, not the raw measurements themselves. Of course, carrier phase measurements, they do relative changes over time. They do millimeter level precision, but they have these ambiguities that get resolved, like I said, via interpolation and previously known values and applying to a model. So without the model, there is none of these positions are known. Just a basic summary. You have the model assumptions from the start. You're assuming that it's in ECF when it's WGS84. The processing itself through the data pipeline will also apply curvature to the data.
Oh, right there again, Shane. Check that line 2 in the box under impact, least squares, or common filters. Optimize positions within the model. Okay. My previous exposure to common filters are telling me that it's just a delightful way to normalize your error and mathematically bury it. All of your, gee, we didn't quite get the measurement rights in a row. Well, we'll just throw them in the common filter and watch them all blend into the number we really want it to be.
Yep.
Shout out to Kalman. He helped fix the drift in inertial navigation systems, the anomalous drifts and anything really that was anomalous.
It's quite the mathematical trick. You got to hand him that.
It's a hell of a trick if you don't look into it.
Yeah. Filters, by the way, can be like, I mean, they can have impact. We were talking, Stone, we were talking in the chat. Daryl thought that you looked very young today. Like, thought that you looked young, you looked great.
Oh, shucks.
And I explained to him that this is the StreamYard, or is that what the Restream filters? Because when I saw you on Discord, you looked much older the other night when I met you. And so I'm pretty sure.
Dude, what? Dude, it was in the dark.
Oh, you're not watching the
Cami,
chat.
it was in the dark. Stone always looks young and vibrant. He's in daylight now.
The lights out. The other night it was late. My wife was sleeping on the couch, and I had to have it. I had to dim it.
Oh, hell, you looked much older, so I'm sure it's all the filters. And again, filters change a lot.
Vanity filters, yes, it must be. But for the
must be
record,
the-
Cami, I'm only about three-ish years younger than you are.
Well,
If that makes you feel insecure, I'm sorry I said it, but
that's still pretty old. It's not. You should be
yeah,
looking
I'm
into
ancient, bro.
Daryl.
I'm a goner. Like, I'm writing my obituary. You know what I'm saying? I'm history. I'm ancient
too.
history.
I'm your grandma in the chat. I know. It's rough being old and so immature. So yeah, but yeah,
I'm
the
rolling
filters
with
are
it.
great. You do. That's all you can do. That really is all you can do. That or shrivel up and die. And let's not do that anymore. Too many people have died.
Oh man.
Speaking of dying, pour one out for the globe.
Yeah, pour one out for Common. Holy crap.
Dude, I'm still thinking about the Restream filter. Like, the Restream adds a filter where everyone looks hotter or whatever.
Dude, I wish such a filter existed. That'd be dope.
Oh, don't they have filters that make you look wonderful or makeup or bandage?
Snapchat or whatever, Instagram.
Not not on here.
Well, maybe there should be, and that's what she's saying, I guess. Oh man! All right, so
there's an internal Kalman filter that's making us look more beautifuler. We are. It's just
corrections.
It's just
Yes, very
auto-correcting
good.
it.
Well, just to take it back to the show, anytime you look at things through a filter, it changes the way you look at things. You see things differently. So we can just run with that.
Yep.
And shout out to our friend Mordwand here. Pointed this out to us during our debate we had about maps and coordinate systems. He was trying to rely on this pseudo-range carrier phase equation over here to say that it's actually independent of WGS84. However, if you look into it, these coordinates right here, xi, yi,
Oh no! Is that a common z-axis alignment?
are directly related to the WGS84 and their position on the WGS84.
Busted.
Oh, unlucky, bro.
Because the argument was, no, it's not related, right? We've deduced the Earth's curvature by intercepting these signals, and now we can see when we plot it, it's a curve, bro. It's a wrap. And we were like, well, no, what you've uncovered is that you're plotting into this reference ellipsoid, and here's the proof in the very equation itself. So another way they get you, sorry.
No, it only makes sense because in other words, you have to, you got to put it in and transform it to your baseline, and they're using the globe as a baseline. So you got to. You don't have a choice.
The
Keep going.
reference ellipsoid is all. Yep. Everyone lives on a reference
Just
ellipsoid.
hail,
Yep.
hail to the.
The other way they get you is with these transformations. The Helmert transformation is converting datum coordinates. So when we're changing from DAT83 to WGS84, we're doing a coordinate system transform which retains relation in 3D space, which then, of course, would also inflict the nature of our coordinate system that we're transforming. So they're all ellipsoid to ellipsoid. And just to wrap up the GPS section here a little bit, the pseudo-range equation itself relies on positions based on WGS84. Everything in relation to ECEF is above the height of a reference ellipsoid. And of course, if we were to go back to the very first diagram, we were looking at how they defined ECEF. It's always in relation to the reference ellipsoid. It's not an arbitrary space in 3D space. It's not the center of Earth's mass. It's the center of the height of the reference ellipsoid. That is definitely what it is. Now, while we're talking about not determining height above what and how we can't determine it, I guess the question we have to ask is level curved?
The
always say-
age-old question. Doesn't level mean curve though around here?
When that came up and they changed the definition, I couldn't believe it. However, looking into it, dude, it's exactly how they define level is curved. So when they use their ellipsoid model, right, they take tide gauge readings from mean sea level from regular tide gauge. They call them orthometric heights, and then they relate them through that. Let's call these, if the geoid and the ellipsoid could be considered a phase or a filter, right? We're going to run them through the geoid and the ellipsoid. They're going to come out spherical. Because what happens is they do a vertical offset. Remember when we talked about the ellipsoid, it had a vertical component, a vertical datum. That is mean sea level, and they use through the geoid and the reference to convert mean sea level to curved. They literally wrap flat tidal gauge measurements around the reference ellipsoid to get a so-called curved model. It's the craziest thing I've ever seen, but here is the actual process, right? So when they definitionally make level curved, like they're right? They're imposing the ellipsoid by wrapping all of these measurements around their model. And this is how they do it. It's with a basic equation, like we looked at before, H equals H plus N, where H is the ellipsoidal height in meters, H is the actual orthometric height reference to mean sea level, and then N is the geoid height above the ellipsoid. So it's a geoid minus the ellipsoid, sorry. And these can be positive or negative. So what I did was grabbed a whole bunch of data from the website, and I undid all of this math, and it turns out most of these are negative. They have negative orthometric heights, which doesn't make any sense. How can sea level be negative? It's only because they're being referenced and subtracted from the ellipsoidal height in the first place. So all of their data is based on this. So the geoid height must be known, the ellipsoidal height must be known at the location, and before they take a sea level mean sea level reading, they have to know both of these measurements, and they subtract accordingly. So you're not actually getting mean sea level, you're getting ellipsoidal normal. Right.
Oh, the old ellipsoidal normal height trick.
Another oxymoron.
Right? The craziest thing. You can't actually have a height H. You have to have little h and other h so that we can subtract from our ellipsoid and geoid.
So we don't just have little g and big G. We have little h and big H. Okay, I'm following.
An N
And
for
then
some reason.
an N, an N.
So then the process outlined simply is, you assume the Earth is curved by you assuming your ellipsoid model, create another geoid model based on this assumption and equipotential gravity direction. You use the geoid as an intermediate layer to correct straight measurements. You claim the corrections prove the curvature. Boom. So then level is curved. That's how it works. Well, only if you consider level water wrapped around an ellipsoid model, then it could be curved. Crazy. The final component would be geodetic surveying, and they use the same method. So again, they're not actually taking measurements of the Earth with geodetic surveying. They're taking planar measurements and they're comparing them to a previously known ellipsoid model. If you look at the American arc of the parallel, you can see not only do some of the measurements not actually coincide with 180 degrees of spherical excess, they're well below that threshold, but they use gratuitous corrections to ellipsoid models, latitude, longitude tables, astronomical latitude. This is going through the American arc of the parallel document here, going through different page numbers with different corrections are highlighted. They're computing longitude and azimuth corrections. They're doing corrections based on latitude and azimuth. They're applying these corrections based on previously known tables. At one point, they swapped out which ellipsoidal model they're conforming to entirely. These are not raw, unadulterated spherical excess measurements that show the sphere, the surface of the Earth as a sphere. These are planar measurements over long distance comported to a reference spheroid that, when proved to not exactly fit, would change the reference spheroid. Right? So these references actually don't fit.
Check it right on that slide you just had up. Go back just one. Right in the center of it, they've got significant figure, 48 degree, 45 minute, 36.35 seconds against 48, 46, 0 seconds, 0.58. Look at the difference between those.
Yep.
That's half of an arc minute in difference of those two figures.
And they say, well, you know what happened was we need a new reference ellipsoid to make that fit.
That's 120th of a single degree of a correction. Okay, boys.
Like they never say, oh, it's not because the Earth's a sphere. It's, oh, we have to sort out which reference ellipsoid conforms to this new data the best. That's where they're at with it. And that's how the whole American arc of the parallel works. Whenever there's an astronomic and geodetic difference, they have this difference coded. This could be one of the first deflection of the verticals, right? They're taking the difference between the astronomic and geodetic latitude, and they're conforming that as different. They also rejecting values greater than a certain threshold. This is on, I forget which page, but it's towards the end where they compile all their data and they throw out ones that don't comport with the spherical model. And they, right in the beginning, they're saying this is one of the first arcs where the corrections have been forced and implemented. So before they used to just take measurements and write them down. Now they have measurements and then they're applying them to a predetermined model and then writing them down. And when you get this document, you'll see that the corrections actually in the data have already been applied. So none of this is raw. This is post-corrected measurements that supposedly conform to the surface of the Earth. They did say that refraction wasn't an issue. That's a lie right here. It's page, 44. Persistent lateral refraction produced the result. They had an equation for it. They were definitely accounting for it. Of course, it's a factor. That's why they were accounting for it and had an equation. They also have azimuth corrections based upon a dozen pointings to a specific star, whenever that didn't align. And then they had just a general remark in the middle that due to the general flatness of the country and the desire to strengthen to their reference triangle grid, they had to do some more shenanigans. But this is the general modern equations you apply for the intersection when they're doing surveys as they're applying them to the graticule or the new lat long grid. Whenever you're using cosine or cotangent, you're applying to you're applying to coordinates based on the stars, right? You're taking cosines of stars, applying to astronomical latitude, etc. So at the end of the day, our terrestrial sphere here is made up of arbitrary abstract coordinate systems with enforced self-referential internal consistent frameworks from which data and calculations are made. So just because the data is all made within a WGS84 ellipsoidal framework doesn't mean that it comports with any sort of curving of the surface of the Earth. And again, if you go back to Ptolemy and you understand the two-sphere model of the cosmos, you'll have a better understanding for how the model works in modernity, with the forced terrestrial sphere in modern times now being called WGS84. And that's essentially it. That's all I got.
All right, real quick, pop quiz. What's everyone's favorite reference ellipsoid model?
27.
Nice. Mine's the Clark model.
I like the Clark ellipsoid. I looked into that one a lot.
Is that the first one?
No, that's the one that they
Oldest one?
that's the one that they swapped in after they realized that the other one wasn't flattened enough.
Oh, okay.
Yeah.
That was the later one.
Yep. This is a more modern, flat one.
The Clark is like the first well-known one. There's one before it, but nobody remembers it.
Yeah.
I looked at AI and I asked AI why the globe can't be accurate. I asked it last night. And you know what it told me? It told me it was too complicated for them to make ellipse spheres. It would be too expensive for them to make. It was just easier for them to make spheres and have them perfectly spheroid. So that's why we can't have a model that works with the elliptical spheroid. Just so you guys know, because I did ask and they did say it can't be done. It's we can do a lot of things, but we cannot make that shape and put the continents on it and have an accurate world map because
Unlucky.
it's just yeah, they said it's too expensive and it would just be too hard to do it to that.
It's for the same reason that we can't recreate NASA's technology from 1960s to get back to the moon. It's just no, we can't do that anymore. It's just not possible. Sorry, guys. Sorry.
We lost that technology and it just takes so much to build it back up. We've grown stupid. I do believe we had grown stupid though. That I really do think we've gotten stupid looking from TV and everything from the 50s. Go back and watch from the 50s, which my line or the different things and see how we've dumbed down. It's not pretty. Not proud of it.
I think we're the dumbest generation to ever walk the earth. Hands down.
Yes, hands down.
Yeah, watch any black and white video of a child talking, and they talk better than most adults do today. So
You've been dumbed down dramatically, I think. Yeah.
Well, it was important. They needed to like make women feel good and not work and take them away from raising their children because it's much more important that you go and do menial labor or all work somewhere away from home and not raise a family or that. So again, it was necessary. Women's lib. But yeah, we're off topic again. I'm doing a really bad job, but I said I would keep you on topic, but it's just too much fun.
No worries. Shout out to Women's Lib. Shane, was there anything else you wanted to recap on or significant stuff that you uncovered while you were going through this that made you you're like, oh, this is extremely important?
Well, we touched on a couple of them, but each of them has their own presentation upcoming, so I chose to let it go. We were talking about
I know there's so many things.
The chronometer, then how maritime navigation works. We could introduce the turn of the century for 1600. I think that's where the globe really came from, where the Mercator came. We touched on coordinate systems a little bit, but people seem to think that the universal transverse Mercator is like something different. It's not. It's just a way that you can use the same graticule to have the least distortion applied in the middle, essentially, right? So it's not using a different coordinate system. All the known mappings are using the same coordinate system. So you're like this one over here. No, not that one. But I put it right. Universe transverse Mercator is one of the other ones that we can always apply. But that's just the way to project this original coordinate system so that it has least distortion in the middle. But we'll get to that coming up, and we'll definitely, I think the next prez I'll do when it's my turn will be the two-sphere model of the cosmos. So we'll be going into that now that we have the basis for the terrestrial sphere.
Nice.
Can I check you on something, Shane, just as a point of conclusion and a perspective thereof that may put some of the globies in a position mentally where they can take a breath? I don't think to me, it doesn't sound like everything that you just displayed here. To me, it doesn't sound like you're stating all this solely to disprove the functions utilized to conclude it's a globe. I think to me, it sounds, because you're bringing up Eratosthenes, et cetera, it sounds more like that you're actually reiterating the conclusion that none of this proves either Earth shape. Do I have that correct? And I say that for the sake of the audience.
Yeah. My main focus was, when do they measure and comport with the surface of the Earth on this? And very little is the answer. But does that change the effectiveness of the model? And to my surprise, not even a little. Nobody cares. Nobody cares that it doesn't measure the Earth. Like, the fact that it's a self-referential corrective framework and it works is all that anyone cares about. So really, that's my conclusion. And not that it doesn't work, it's that it doesn't actually comport to the surface of the Earth.
Yeah, what you said, Stone, about it being not proving either one, super important, especially when it comes to tying it all together with the fictitious observer to make it all happen.
If they were trying to prove either one, they would have measured more than the minimum threshold that they outlined, right?
Well, I think in a very base way, that everything that we've just put down on the ground right here is congruent with the conclusions we draw, logically speaking, about what happened with TFE. That we're looking at the sky and it's not really telling us anything about the ground.
Yeah. Yep.
Succinctly put. I think that's where we're at here.
It's not telling you anything without referencing the coordinate system, which requires fictitious observer and all that.
Assumptions about the ground. Yes.
Right. Exactly. All
Nice.
right.
Yeah, so that's
All right.
everything I got for this press. Good stuff.
I got a couple of notes that I wanted to go over, some fine points here. So on the gravitational, I'm sorry, for GPS, one of the things we talked about, or that Shane talked about, was astro-geodetic deflections, which is gravitational potential corrections. Now, they're saying that a physical plumb bob on a string is deviating because of this gravitational potential issue right here. Now, if that were true, then the light that the radio waves that they're using from GPS would also be affected. It would have a frequency shift due to the gravitational potential offset there. So there would be like latitude dependent gravitational potential correction offsets. None of these exist. They all, what they end up saying is that because the Earth's an oblate spheroid that deviates from a perfect sphere by, what was it, 58 meters or whatever, Shane? Just like some ridiculous amount, because it's oblate and it's rotating through a stationary gravitational field, however that works. It's just like magically offsetting it, creating a nice smooth equipotential gradient that requires no latitude dependent corrections, which is preposterous.
Now, I have a
It's-
question. Are they sending that information to the engineers and builders so that when they build, they ignore their little plumb bob and they build it at the correct angle to go down? Because I can like I just want to make sure that they're passing on their information and people know what direction down is, because I know in engineering it is super duper really, really, really important to get it right. Not only is it right to get in engineering, but I can tell you in a lot of fields, like I was in the jewelry industry, so we weighed a lot of diamonds and I had like portable scales and, did legal paperwork. Scales to be legal. Any legal scale for trade, scale for legal has got something on it called a level, a little level bubble. If you actually do weights and measurements and do them for legal things, you'll find that the very first thing that you need to do is make sure that your scale is level, because if you don't have it level, your weights are off, especially when you're doing that. And that is like 101 in setting a scale. So are they telling, like, if I go to these places and I was going to do business, do I need to ignore the level on my scale and weigh to that? Or, I mean, do I apply that practically
Yeah.
or only when I'm looking at the stars? Like,
Yeah,
again, are we engineering?
So each place you're going to go do building at, they're going to have like 4 different datums that you can reference. So Shane was talking to a surveyor one day, and so like the guy that they're going to hire to go out and survey everything and find down for them is going to be given like 3 or 4 different references to help him find down in the correct location, so that by the time everything is measured and sent out to the people that are drawing the plans, they can just do it normally, because it's already been confirmed by the 4 different data points to
Things,
check and
but
all that. Yeah.
but they can just run their little plumb bob and follow that, and even though it doesn't match, it'll be okay. Maybe because of the microgravity there or whatever's causing it.
Well,
Whatever's deferring it.
So Cami, it'll only be okay if it's within the threshold of their favorite selective datum. Otherwise, they're
Okay.
out of tolerance, and they're not gonna. Then they're gonna be building a building that's like Leaning Tower of Pisa style. It's gonna be off.
I can't, yeah, because they never, ever, ever approached
No.
that I needed to work on that when I worked on level, but level was definitely talked about in application of, real world at scales. Definitely do not like to not be level when working. Again, if you're measuring carats and things like that, you gotta level your scale. It's 101. And this, again, a scale that fine doesn't exist without a level. It can't. It can't. You just can't do it.
Yeah. Well, that's why they had to redefine it and make it curved.
Yep.
And then another thing that was brought up during the
It's all
Prezi
clear now.
Yes, was the units of measurement, the stadia and Eratosthenes, and how like the big significant part of that story wasn't the angles to the sun and the out and like assuming close or far, none of that. The significant part was that the unit of measurement, the stadia, was the exact distance that it is with modern units of measurement. So Shane, if you could touch on what a unit of measurement is in relation to the self-consistent coordinate system that it was once derived from, and why these distances match up, why you can reference positions of the stars doing trigonometry, calculate the distance out, and it works with a mile, it works with a kilometer. What's going on there? How does it work? It even works with the stadia. The Greeks knew, bro. How'd they do it?
Well, first of all, dude, I should say that that book, Geography, is like a made-up plan, right? If you read it, it's supposed to be written by one person. It's got like 7 different personalities, 7 different contexts. Like the experts all agree. Actually, it's either written by a person with severe schizophrenia or a collection of other authors, right? Like that was the academic consensus. So they put it there to put the whole basis in there. And what they how a dude would know where everything was all over the world in modern terms and then sat for 1700 years before anyone would use it is also asinine, right? However, the only unit of measurement that has a relationship to actual distance is the nautical mile. They relate the nautical mile to an arc minute along the Earth's equatorial circumference, right? So they're using the spherical coordinate system to determine 1 arc minute of that length, and that's how they get the actual length of a nautical mile. And then all the other units of measurement are ratios of that, right? You don't define an inch you define an inch in centimeters. You define centimeters in meters, meters to feet, and feet. Like it's all ratios of each other. So the modern metric system is really just tied to the shape of the spherical Earth. That's how they did it, with the nautical mile being 1 arc minute travel along the equatorial circumference. And then, of course, how they calculate that is 1/10 millionth terrestrial meridian is how you get 1 meter. At the meter convention, they decided that a meter should have a reference to everything real, so they related it to 1/10 millionth of a terrestrial meridian. So if you take north to 90, so 0 to 90 degrees, and you do 69 statute miles per degree, 69 times 90 is 6218. And then if you convert that to meters, it's 10 million, or sorry, 10,000 meters. 10,000 meters from the North Pole to the equator, and then a meter is 1/10 millionth of that. Crazy.
Fantastic breakdown. Thank you. That explains the internal self-consistency of why these things work. Because they'll be like, because we'll hear arguments where some will say like, how come I can take this, rods and chains or whatever, and measure out the distance and it matches? It's like, well, is it a unit of measurement derived from the coordinate system that's defined by positions of the stars? All right, that's a good one to go over. And you mentioned cosmography at the beginning of the Prezi.
Yeah, so Ptolemy's fake book was written by 6 different people, also goes under another name called cosmography or cosmographia. And I just like that because cosmography is the term that it used to be. It combines the cosmos with geography, or what we're doing combines the stars with the Earth, right? You can't map the stars without the star, without the Earth. The whole model, the terrestrial and celestial, combines the two. So I think the term nicely describes the combination of the two. And in modernity, they separated them. You have cartography and cosmography and geography, right? So they made them separate on purpose, and they try to tell you that you can have geography without the stars, but the ancients knew better. You can't. They are one and the same. They are entwined.
Yeah, that's a hugely important point there, that they're not independent of one another. They're all part of the same thing, and separating them is how they've, confused everyone. All right, well, let's see. No one has base measurements of the ground of curvature, right? It's all in reference to the external reference that they have, which is the stars. So this is what led to the deflection of the vertical and all that. So yeah, everything, all my notes are covered. Fantastic presentation, man. Great introduction into how the globe was built and constructed. First, one must presuppose the globe and never stop.
Just assume, and then you never worry about it. It's fine.
And never take direct measurements of the Earth's surface.
Ooh, quick retort to that. If you do, make sure it's under 70 kilometers so that it can't be statistically significant to determine anything. And then just calculate the rest based off the position of the stars. Whew.
Less than 1%. Crazy, right? I think they'd make like an effort to do more than that. Nope.
All right.
I do have to say really quick that measuring the Earth like ground accurately, we went out, and how far did we measure? Not very far, as we made it a half mile, or Karen? We did a survey.
Oh no, actually I thought we went like almost 2 miles.
Oh, did we go almost 2 miles? But how much work was it? I mean, we were moving the theodolite and the surveying, and we had to triangulate like 4 pieces of things every time, set up pins, level things.
Yeah, because we were like leapfrogging with the equipment. So it was like before, when we measured the last one, we take the levels and move them down the line. And then, and then Chris would go do his thing. And then I was like sitting there, and he'd read off numbers, and I'd repeat it back. And like, I just know there was just like this page full of numbers when we were done.
We had some. I have screens full of the numbers and how tedious. I mean, it was super duper 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 tedious. I got to tell you. I mean, we got it done, but to
Was.
do it, and we didn't. By the way, we did measure the ground, and in Colorado, with the professional surveyor, we didn't get curvature. I'm just saying.
Mm-mm.
Mm-mm.
Never met her, huh?
That's
Nope.
what, like I said there, and do with the different things is like, I've physically gone out and measured the ground, and I've done a lot of different things that, like, done a lot of the work. It's
How dare you measure the ground without referencing the stars to find the curve?
I know we did it during daylight and everything. We were crazy. We were crazy out with the prairie dogs. We were wild.
Mm-hmm.
And all
We're out there for a long time.
we
awesome.
were. It was.
All right, so I refreshed the chat, and the whole, like, most of the history of highlights is lost now. So I've got a couple of questions, but not all of them. So I'm going to go through a couple of them here. So have you ever noticed during the datum transfer do they do anything to compensate or to hide a larger radius value or circumference value?
No, the transfer. So like that's between the flattening factor and the major and minor axes. So they're not really hiding anything, and they're all showing the same data. They're just showing different variations of sphericity, right? This one's a little bit more spherical than the other one by like 6 meters.
Awesome. All right, we got. How can they deal with the definition of curve along with the distortion of flat? Not really.
Just like that.
Yeah,
Well, you can deal with it by like. And,
All
okay,
right.
next question.
Yeah, if you well, that's all I got because, like I said, I refreshed the page. So I only got 2. So if you guys have any from your chat history where you see GLOBEBUSTERS being tagged, read them off.
No, Shane, I don't have that, but I have like a complaint to you that Karen and I joined because we were going to stop you and explain out more where you guys were getting confusing. But you blew it. Like you let me down. you gave really, really good information, but I didn't find you got confusing at all today.
I didn't feel the need to interrupt at all.
At all.
Don't squash that urge if it should come up though.
We won't, and I can tell you because I spent some time with Karen. Karen's not hesitant about being very, very vocal.
I know,
especially if she's about shenanigans and that. So we will that's what we really want to check and challenge and not do that. But I thought that the presentation today was very, very, very clear, easy to understand. I learned some things from it, and I've been studying this a while, and I wasn't totally bored, even though it was like math. And so that was. I'm grateful.
Nice.
It was actually very fun. It was very fun.
I saw a lot of scary equations. It made me very intimidated.
There was more on the back end that I chose to not show. For sure.
We can always find more math.
Yep.
Yeah, the math doesn't scare me as much as it annoys and bores me. I can't. Some people can get excited by it. It glazes me. It glazes me because I found so many things in reality that don't work even with math and that.
You mean math isn't reality?
Not always. It can describe reality really good sometimes under certain situations, but you know what? There are other parameters that it can't do it at all. It can't capture it. It can't,
Well, that's why they had to introduce numerous corrections to make their coordinate system fit reality.
Mm-hmm.
Right? They present it as if like math is reality, but it's not. It only is if you introduce unlimited correction factors to make it fit, and then you can go, yeah, my math is describing reality. Oh, okay, fair enough, touche.
It's just like putting in the Lorentz transformation and that into things too. It's like, yeah, if you transform it over to our stuff, it will work. If you take this and transform it and don't take it, then your math will work. So it's it's crazy.
My main takeaway from doing all this and thinking about it is like, if this is what we're fighting, right? Why would we want to replace this? This is a working model. It just has nothing to do with the shape of the Earth underneath it. It works completely arbitrarily for GPS satellites, mapping cars, anything you want to use it for, autonomous robots. Like, we're not going to replace that. We're not going to be fighting that. That's why I was trying to get it to, well, here's what it is. Here's where they measure the Earth. That's the part we can fight. The rest of it just, it's reality. It works.
It is reality and works, and if you projected it again, it's they prefer to project it on the ellipsoid, but again, you can project the map out multiple ways, and we don't know. I personally don't think it can be projected out accurately without cutting some lines. I believe you can get all your lines and things on there, but I think you're going to have some. I have reasons for thinking that. We can get into it later, but and I can see how you could say it wouldn't work with the stars, but I've thought through that too. There are possibilities, but why does it matter? Again, that's why are we compelled to do this? We have a map that you can drive. You can type in your GPS. I can drive over to Karen's house. I can probably even get to your house without ever being there before on the most direct route in the fastest amount of time, if I wanted to. So I see that, but they're dumbing us down and they're lying to us. And don't you want to know why? I mean, don't you want to end the world that we're leaving for our children? I'm not so proud of being an old person here. I'm really
Well, and they also use it to sell fantasies to adults, like, oh, we're going, like Elon all the time on X talking about how he's going to Mars and we're sending people to Mars, and and we have to become interplanetary species to survive, and like, it just sort of is like it's all a big like psychological game. They
power.
play with it too. Exactly. They're putting people under a spell, by giving them that sort of like, it's almost like a nihilistic sort of, idea. Like, oh, we're just little specks of dirt on a ball, on a soggy pear in space,
There's one other question here I found in the chat from RG at GLOBEBUSTERS. Back then, quote, did they have an exact methodology or an approximate rounding up or down on land versus sea? If you can make heads or tails of that.
I choose to interpret that as the history of the definition of the nautical mile. And there's been definite definitions from the Roman pace all the way up to modernity. And I think the French had a different definition of the nautical mile than Spain did, all the way through the Renaissance. So like that also relates to like knotting, when they did the knots and how they determined a knot at sea. So then really all miles are deduced by nautical miles, because there's so little land comparatively on the earth that they had to figure out the method based on at sea. So then that's why you end up with things based on the stars.
Yeah, I think we've got the same thing going on with the development of the stadia. A stadium, you know what I mean? How long did that turn out to be?
Arguable, yeah.
Difference in 300%, yeah.
Yeah, there's no definable metric for it. It's just something scholars agree upon, and you have the freedom to agree that the stadium is within 1% of a current terrestrial meridian, or 16%. So you could choose how accurate you want to believe Eratosthenes was within that threshold. No more, no less. So I'll let you decide. I don't want to tell you which one to pick. I'm personally a 0.3%.
I'm
myself.
adding them. I think that we should add them together and have 17, because 17 is in my.
No. Then he wouldn't confirm the globe. No, that's not what we know. It's 16 or 1. Whew, that was scary. We almost lost the globe, boys.
Sorry about that. I didn't mean to. I could grab the metaphysical people though with the 7 and the 17, saying the wavelength and 717, and your harmonics and that. So we could lose the globe and pick up. But again, it's wherever you want to go with it. But yeah, it's fun. It's fun how they do the things. I think nautical miles and the way they did the knots, that was fascinating to learn that too. The knotting.
Yeah.
I can tell you that, like, studying this, you really do learn so much on how much they haven't taught you in school, what the little box they keep you in.
Yeah, the one about maritime navigation and how they applied this is actually super interesting, because you get into the history of how it was sort of fudged and how they just dropped a whole bunch of history on us, and they told us, well, actually, here's what happened over 300 years. Take our word for it. I love that part.
One of my favorite excerpts from that is the Royal Society worked with the guy that made the first chronometer. They worked with him for 30 years. The guy never made anything before. Nothing. They worked with him for 30 years.
John Doe or whatever, the hero of the age, John Harrison. Yeah, dude, crazy.
Did they even make him like an honorary royal lad or what?
No, I think they took all his IP and then sold his right. That's what the contest was. Come show us your stuff and we'll profit from it.
Respect, dude. All right, so I think that pretty much rounds out the hour there. We're going to go ahead and wrap up. Thanks everyone for joining us on this new season of GLOBEBUSTERS, season 14. We hope to see you again for episode 2, season 14. Next week, Stone is going to be presenting shadow sets and the implication of using a triangle to determine where this, is the sun above or below the horizon when it's setting. So we're finally going to get an answer to the age-old question: does the sunset prove the globe mutually exclusively? Because the only thing that could set that bad boy is a giant curve.
Can't wait.
It's gonna be a good
right.
season. I'm glad we're back.
Yes, sir. Stone, Shane, Cami, Karen, thank you all for joining. See you guys
Yeah.
next week.
Yeah.
Thank you. Thank you
Yeah,
for
hopefully-
having us.
show.
Yes, sir. Hopefully your air conditioning's fixed next week.
I'll be working on that for sure.
All right.